Hi, everyone. Thanks for tuning into the Printed Circuit podcast, where we discuss trends, challenges, and opportunities across the printed circuit engineering industry. I'm your host, Steph Chavez. In this episode, we'll focus on RF PCB design. Here to join me in this discussion is my colleague, Per Viklin, Director of IC Packaging and RF Product Lines at Siemens. Thanks for being here, Per.
Thank you.
Can you give our audience a brief introduction of yourself and your background?
Sure. So I'm Per Viklin, as you said, and I'm responsible for product strategy and technology for our solutions for RF and microwave design, and also IC packaging. Not quite related, but those are the areas that I own. And my background is in electronics hardware engineering, as well as in EDA software engineering. And by now, I've been in this industry for the past 45 years. I can't hardly believe it myself. And I joined Mentor Graphics, which now is Siemens, in 2003. Already at that time, my focus was RF and microwave design and not so much IC packaging, but what we called advanced packaging back in those days.
Awesome. I tell you, 45 years, that's a lot of battle scars.
Yeah, I'm old. That's what you can conclude from that.
No worries. 2003, that's the time when I really started running with Expedition. So it's a great year, the way I look at it. What is your history with working with RF PCB design? Let's start with that first.
That kind of started almost as a child, I would say. I've always been an electronics nerd. So as a teenager, I was building hobby projects, and also I was a radio amateur and built my own equipment. So that's kind of how it started. I met an old guy who knew everything about it, and he pulled me into amateur radio, ham radio, and starting building, tube amplifiers and stuff with microwaves. And it kind of tickled me. It was really fun to do, and I've done that for a long time. Then in my work, I wanted to do something that had to do with electronics. So I started with electronics assembly and an assembly line, and then moved into electronic design, circuit design. And that's where I first got in touch with actual RF design. And then it took quite some time before I actually moved into software for EDA tools. And my focus from that very beginning was actually the part of the software that had to do with RF microwave design and advanced packaging. So for a very long time, I've been involved in doing that. So doing the software doesn't necessarily mean you know everything about the technology as such, but there's a real advantage in working with our customers. And over all this time, I've had the opportunity to work with many of the most advanced RF companies globally, really. And it's been a very rewarding journey, and I learned a lot from them as well. So in this world, you learn every day something new, and that's true also still for RF design.
You definitely have to be open to be in this industry, especially a board designer. Actually, engineering in general, you've got to be constantly learning and evolving as the industry unfolds. The industry doesn't wait for anybody, so it's behoove us to stay on top of new technology and new methodologies that are unfolding, and the best practices, which Siemens is what we bring to the table, is of how we do things and what we offer to the industry. When I think of RF, for me, I think it's back in the day when I first started. I started with RF. It's like black magic. It was like very mythical, and it was very challenging, and not very many people knew how to deal with it. And you learn, like I mentioned the term battle scars. You learn by making mistakes. And I think it's one of the awesomest boards to design, or that domain is the RF. That's, my favorite because of the challenges that you're up against. Can you highlight some of the challenges that you might have experienced when designing RF designs?
I think I want to give a rather generic answer to that, right? Because RF doesn't quite behave like lower frequency signals do, but in all honesty, they actually do behave the same. There is no different physics for these, but at lower frequencies, it doesn't matter so much. But all the challenges that you have doing RF microwave boards are based in just that fact that there are different behaviors of signals that matters at these frequencies than matters at lower frequencies. And that's something the designer must keep in mind always and constantly take that into account, right? So one good example that we run into often is that in RF design, we often work with multiples of quarter wavelengths of conductors. And we do that because at those multiples of quarter wavelengths, we have a certain behavior of what the voltage minimum and current maximum, and the opposite, with the current minimum happens at those distances, and we can use that for certain things. So, for example, in something we see a lot is that you come in with a signal, and after some quarter wavelength, it's actually connected to ground. And most design tools have some problems with that. They will think that you have a short circuit, and they will start to challenge the designer in understanding if there is a problem or not. And that's not really trivial to deal with in a design where you have hundreds or even thousands of RF blocks in one design, right? This technology gap that the tools couldn't handle that used to be a major issue when doing RF design, especially in the context of full digital analog systems, which you almost always have today. It's rarely just microwave. So you have to have RF and non-RF in the same PCB. And we have now added technology to our solution that understands this difference to help you manage this challenge. But it is there behind you all the time that the signals behave a little different on these RF boards, and you need to take it into account.
Early in my career, it was difficult to have the tool or utilize the tool to control when you're dealing with RF, as you mentioned. Some of the techniques that are required when you're bringing in the shapes or when you're trying to lay the circuit down. And it's back in those days, the tools weren't as powerful as they are today. And with all the capabilities we have, it's amazing.
It led to a lot of design iterations back then. And today, you can't afford that anymore.
You're exactly right. Today, the goal is to design it correctly the first time and to minimize your respins, so that way you get it right the first time with the highest yield and lowest cost. That's the ultimate goal. When we talk about analog digital RF co-design, can you explain what this is to our audience?
So here's the thing. It's really rare these days that a design has only RF or microwave on it. It's almost always a combination of some digital and some analog circuitry together with the RF. And these circuits, they can impact each other. That's known by most. And in most cases, it's negative impact. So we have to handle that. It's often called just circuit interaction, which sounds harmless, but it can make the RF fail, or the RF can make the analog circuit fail, and so on, and it can even make the digital circuit fail. So to handle this, you cannot just design an analog module, a digital module, and an RF module and put them on a board and wire them up together. Back in the old days, that's what we tried. But what you really have to do is you have to design these things more or less in parallel. And when you design the RF, you have to see what's going on in the analog and digital parts and vice versa. So when you design an RF microwave, you do it in the context of the full system design rather than just looking at your little microwave circuit. You have to consider the whole thing. So with co-design, I really mean that each design, each domain in this design, RF and PCB design, can design their piece of the puzzle with full insight in the other domains at the same time.
I think that's the biggest advantage we have today is with the capabilities of the tools today, you have this instant dialogue of being able to communicate and work simultaneously, concurrently versus in silos back in the day where you'd bring in the analog section in or you'd bring in the digital, then the RF, and then
you pass the data over the wall, right? That's kind of a phrase that's been used a lot. Not possible anymore.
You can't. Those days are gone. How does printed circuit engineering continue to evolve when we develop RF design skill sets when it comes to continuing education? Because as you and I can attest to, back in the day, it was school of hard knocks. But now, how does a designer today get educated or continue their education or development?
It's kind of an interesting question in many ways because there's a bit of culture difference in different countries or even in different companies. In some areas, I see printed circuit board design being a task that's done by a technical draftsman who may have lots of experience and know how to do things right, but they're generally not double E in the background. And then in other companies and in other countries, it's more or less tradition that the PCB designer have a master's degree in electronic engineering, which gives at least a theoretical background that is very helpful, right? But we have to accept that PCB is really no longer a mainstream step in the end of the design process, because now it's really a critical path to successfully land a project. And you have to be prepared, right? So continuous training and education is really critical here. So as in most fields in the workplace, right? And organizations like IPC and some of the conferences like the PCB Design Conference, they offer a lot of classes. Some of them are short, some of them are longer. That helps you stay ahead of the curve of this technology. And I would really encourage designers to constantly go to these types of training. And we also know that, successful companies know this and encourage their employees to participate in these types of trainings. But there is no shortcut. You really have to go to regular trainings.
I couldn't agree with you more. When you talk about industry conferences or associations like IPC or PCA, which, I'm the chairman of, you have PCB West, PCB East, and you have PCB Carolina. These are excellent sources of industry conferences where you can get straight from industry experts or subject matter experts who are sharing their knowledge and passing, lifelong experiences, to the new generation of engineers or any engineer that's, attending these. I think throughout my career, I would say like 90% of my education as a designer has come from attending these conferences because of the golden nuggets that they provide. So I can attest and I cheerlead or echo, your statements about continuously attending these conferences if they can. And companies that understand this and allow their designers or their engineers to attend these conferences, it's a win-win. They benefit the employee for professional development, but as well as, helping them design better products faster, more efficiently, because they get a better understanding of what's the best practice for today. And the key is also dialoguing with other engineers, sharing the experiences and networking. I mean, that is huge today.
And one reason why this is so important also is even if you studied to be a double E, you know all the theories and mathematics behind the field equations and everything, but how does it actually relate to laying this trace down on the PCB? That's not described in your school books generally. That's what you learn on these conferences and it's specialized classes that look at how the theory applies to the practice.
Engineers, most, especially in the US, most state colleges or universities, they lack or they fall significantly short in a curriculum for printed circuit engineering when it comes to designing circuit boards. They have great electrical engineering programs, but you get electrical engineers come out of college and then they're hired and the first thing they're tossed is, here, we need you to design a board. They have no clue. And unfortunately, they're not sure where to turn to, and especially if they're young in their career. And there's where multiple revisions come into play over and over, and it's very costly. So I think it's key to get to these industry conferences and add to their collective of the new generation of engineers, which are usually double E's coming out of school, these new printed circuit engineers versus back in the day when I started, they were draftsmen. They were considered draftsmen or people who didn't have double E degrees. It's different today. Tell me, Per, what tools would you recommend for RF PCB design?
This needs to be tools that really understands the difference between RF and non-RF, because otherwise your RF circuitry will become some form of just dummy metal. Many of your intelligent tool functions you would otherwise rely on, like design rule checking and smart plane fills and so on, wouldn't function properly, and you will end up spending a lot of time manually managing everything and manually cleaning up data after RF tool import and so on. So the traditional PCB design tools didn't handle that very well. But at the time, Mentor and now Siemens have developed PCB tools that has this core concept built in to the tools. And I've had that for almost 2 decades by now. So if you look at our Expedition layout and our PADS Pro tools, they have this built into their cores and can handle this. And then you must not forget, right, that the detailed RF structures are very rarely built in these tools from the beginning. They end up there eventually, but initially they are probably built in tools like the ANSYS HFSS or Keysight Pathwave, which is used a lot for designing the actual RF metal. And you then need to integrate it into your system design. And there is going to be a lot of round trips with this data before it's final. So it's really critical that both the PCB tools and these tools for RF design can talk to each other in an intelligent way. So you don't lose data when you transfer from one tool to another. And also that you don't have to do any manual cleanup, because after 5, 6, 7, 8, 10 round trips, you're going to be really tired from cleaning up data. So that's important as well, right? And we've seen that having this level of integration where you don't translate data between the RF design tools and the PCB design tools, but have a data foundation that understands both sides of the picture, you can actually save more than 50% of the total design time. So it's not just an interesting observation, it's really important. So I would say on the layout side, it is the Expedition layout and the Pads Pro tool for you. And everyone in RF design also knows that on the design side, you'll have HFSS and Keysight Pathwave, or ADS as it was called before, are where the circuit is constructed, and then integrate this whole thing. That's the integrated tool scenario that we see with most customers. These are the tools, and they constantly talk to each other and refine circuits.
When I think of board design in general, and I mean, of course, this applies to RF and microwave design as well, there's three areas that have to be covered, and I refer to as the designer's triangle when you talk about designing boards. And, the first was layout solvability. And in that, you got to master your tool sets. And this is where this comes into play. What you're talking about is the capabilities of today's tools. They're very powerful, and you got to learn to master the features and capabilities within those tools. Then you have, the performance of the board. That's where your signal integrity comes in. Today, I think you would agree with me. You've got to simulate and do your analysis. I mean,
all designs are being simulated today.
Performance today, I mean, the RF and microwave, those are, considered complex designs, and you've got to simulate your designs.
And in multi-domain, because even if you have an RF design tool in there, you will have a SerDes channel somewhere in this design. You need to see if your RF is interfering with that and closing your eye for you. It's not just simple signal integrity. It's considering all the effects.
You're absolutely right. This is one thing, in my experience, especially in the mil-aero, most projects that come to the table and say, oh, we're already going to have 3 respins. And it's like, we can eliminate if you just give us the time to do simulation. And the engineering team will push back and say, if you allow us to do our job, we can eliminate a respin. Just give us time to do the analysis. And usually, one of the things that they're looking to cut is to reduce design cycle time and say, well, you know what, we're already going to do respin anyway, so we won't do analysis on this board. We'll do it on the next one.
That has changed, though. It was like that. But I think these days, everyone recognized the value of simulations, and they're learning how to use the features as well. When we were new with these new RF tools, people tried to use them just like they used their old tools with the old methodology. And then, of course, you don't get the advantage in shorter cycle times. But these days, the designers and organizations putting new tools to use, they're very good at making sure they use every bit of it as well. Because you can't afford to be slow in design these days.
No, you're exactly right. And it helps, as you talked about with Expedition, the solutions that we offer, it helps, when we're all in the same ecosystem, and communication between the different domains and how we integrate, it's unique in itself. And that gives the advantage of being able to move very efficiently and get it right the first time. As a subject matter expert, what advice would you give to the new generation just getting started in this career about approaching RF PCB design?
I think you really must acknowledge that RF PCB design is not black magic. There's still people trying to convince you it is, right? And you remember in the old days, everyone thought it was black magic, which of course wasn't. But everything we do in an RF microwave design, we do for a scientific reason. And the modern design tools we have will help the designer in many ways, but you can never replace the fundamental understanding of the RF theory. So I would say the key bullet is that you need to make sure you're educated in the fundamentals of RF theory. And even if you're not interested in learning this to the level of a double E, there are a few fundamental principles you really must understand. And they're taught in any RF 101 class you can find, probably, right? So they will cover things like electrical and magnetic fields, wavelengths, reflection, standing waves, reactance, resonance, and Q. And you don't have to be an expert on all that. Well, it helps, of course, to be an expert. But if you're not, basic understanding will take you far. And above all, understand how these effects relate to the actual PCB layout. That's even more important than fully understanding the mathematics behind them. And I would say if you want to do RF design, you've got to make sure you have a basic understanding of all these effects. And if you don't have it, you need to go and educate yourself on that. I mean, even if you are double E, you probably still would need some help understanding how the physics applies to the real design as well. So taking some classes in this area, that's what advice I would give.
That's great advice. That's great advice. As we're coming up on our allotted time here, is there anything else you'd like to add or any comments before I close this out?
I think we pretty much covered it, to be honest. We could go on forever here, and I hear you've been in RF design for a long time as well, and I bet we could share a beer and have real fun. But I think there are just a couple of things to recap, right? You got to understand the technology, and it is not black magic, right? So if you're interested, you will figure it out. You don't have to be a double E, but of course it helps. And then you got to use the right tools that understands what you're trying to do and not fight you instead, and you and I remember the tools back in the days, they were really fighting you because they thought you were doing a digital PCB and you were not, and it constantly tried to make problems for you. But we're not there anymore. So with the right tools, this will be efficient. So, and there's more and more RF happening. I mean, I'm not sure if you read about it, but as more advanced cellular communication is coming, and people are starting with beamform antennas for cell phones and stations, and we go to digital beamforming, these systems are more complex than they were in the past. And the general designer that in the past would never see a design like this will now be forced to do these type of board designs. So this now happens to pretty much everybody, while in the past it was the few specialists. So I think that's also a good takeaway, that this is not some rare technology that some people work with. Most people will actually have to do this one day or another.
I agree. You know what? I couldn't sum it up any better than what you did. I think that's the evolution of the industry. It's a great time to be a board designer. That's the way I look at it.
It is.
Well, I think that's all we have time for today. Per, thanks for sharing your insights on RF PCB design. To our audience, continue to tune in for more trends, challenges, and opportunities across the printed circuit engineering industry.